I'm building a timer circuit. I need an enclosure. Doesn't really matter for now. I need to be able to take a 30 to 40 volt power source and switch on about 5 volts at 4 amps for about an hour and a half. So this unit here is a timer module from eBay. This relay here switches these terminals here. There's normally closed and normally open, so I need it normally open so that it closes for an hour and a half and powers my circuit. It has a button input, it has a power input which wants 12 volts. So this board will make, and it's a bit over spec, but my lightweight boards won't handle the input voltages I'm working with, so got to use a good one. Here's the input voltage, makes 12 volts, powers this board. This can now switch my output with the timer. This board will produce apparently up to 10 amps output, and so this will also get powered just like this will be. I just got some of these DuPont things. I bought these ones that have got a prong on a male on both ends, and they have been fairly useless, but this is a perfect application for them. So we can power that, and we can power that from the power supply, and then we need to join, because I don't want to put it all in the box and find out it doesn't work in the way that I hoped it would. I've already had to flip this module over. These traces here are tinned for extra current carrying capacity, and they were sort of, they were somewhat tinned in parts, you know. So we need to connect this fellow here. Well, it's done up tight. This will give us 12 volts output in theory, but we'll check that before we go any further. So what have we got? This is in minus is white, and in minus is purple. In minus is white and in minus is purple. So I should, in theory, got to kind of cross these over and then clamp them together. Sort of. Yeah. Yep. Confirm that. Minus white and in minus purple. Yep. White and purple, which means that we'll just confirm that we've got blue and grey. Grey in plus and blue in plus. Never mind. Probably got my giant mop of hair in frame then. I'm going to do a lot of this. I might just create some terminal strip that I can just plug these things into. Turn the power onto the power supply. Turn on the power supply. This is a Ryden RD6024, so that's 24 amps, and the way I've got it set up, so up to 60 odd volts. It's I gave away a Digit of Precision for just immense power. Yep, they're connected up to the red and black in the right way. V set, let's make it 40, and we will leave current at 0.1 of an amp. Should be heaps. Turn that on. No, that current's not heaps. So that's dropped to 17 volts. That's current limited. The LEDs have come on, which is pretty sweet. I don't know if you can see those. But we're going to turn the current up, given it hasn't exploded on us, and the LEDs have come on, which suggests all the polarity's right. Oh, we'll make it 1 amp. There we go. So this draws 5 watts. That's troubling, actually. That's more than I would have liked. My plan was to switch the 5 volts with the relay, because with DC, when you switch DC, and you'll often see 2 different ratings for a relay, like this one, 10 amps, 250 volts AC, 10 amps, 30 volts DC. And that's because when you switch AC, it keeps passing through 0, because it's a sine wave. And the spark doesn't extend between the switch contacts. That said, I'd be trying to switch 40 volts DC, but maybe at like, well, you know, some less than an amp. But what that means is that this circuit, if it's connected to power, will sit there and draw 4 watts doing nothing. And it's going to be more than that, because it's also got to be powering the timer circuit. So let's do that. Out minus is green. Oh, that's just serendipitous. And out plus is blue. That's the 12 volt module. Yeah. Turn the power back on. Woohoo! So according to the power supply, yes, it's 5-ish watts. More than I would have liked. And so I've got this little jumper here set for minutes, and then there's a trim pod here where we can set how many of them. Right, and then if I trigger it, these are endlessly useful today. If I trigger it, this is marked key here. If I trigger it, it should start counting down. Yep, click, I heard the relay go, green light came on, and that should start counting down. And then the output of this, the positive will go into common and out through normally open. And that'll be that. This should say 98 before we know it. So yeah, this relay just has to switch this. Instead of going directly to the load, one of the wires goes through this relay, and so the timer can turn it on and off. But I'm definitely going to need a master switch over here. I can't leave this plugged into a battery indefinitely. The good news is this covered in LEDs, so it should be apparent to me when the whole circuit's turned on. And I mean, you know, with a kilowatt hour battery, I mean, it can be left on for, you know, hours and hours and hours and hours without any real problem, which is unlikely anyway. But it can't be left on permanently, because, I don't know, 5 watt hours per hour, 10 hours is 50 watt hours, 20 hours is 100 watt hours. See, it's not okay. That's 10% of the battery. So, yeah, disappointingly high, actually. Yep, 98. Huh. It's it's works. I don't know if you can. 97. Ha. Might have even caught that on camera there with my hand shading it. So this stack up works. And I didn't measure the voltage of that before I turned it on. That was NFG. We'll just have a quick look at that. Might as well get it the right way around. Geez, that's nice stuff. These are just modules from eBay. This is currently set for 28 volts, which is way higher than I'm looking for. We just, as Dave Jones would say, get our tongue at the right angle. I'll see if I can find a spot for this where you can see it. Never mind that I'm now in a bloody great knot. So, tongue at the right angle, get on this multi-turn trim pot. Wind this down to 5, 6 volts, 5.5 volts. .3 volts. Yeah, about 5.5 volts. So, there we go. 96. Oh, look at that. It works. That's pretty exciting. I mean, there's, well, the box from my local electronics supply store was 20 bucks. And I suspect that these modules altogether probably didn't cost a whole lot more than that. But you know, I'm in for 50 bucks for a timer circuit. But that's where you get to sometimes with these things, isn't it? That's what the project requires. Anyway, I guess I've got some drilling and tapping to do. I'm going to put the these boards in the bottom, and I'm going to attach this board back into the lid. I can seal that plenty well enough for my purposes. It's all low voltage, so it doesn't really matter. But yeah, there you have it. A whole bunch of off-the-shelf modules. They're all switch mode. They'll run nice and cool. This one might get a bit warm at the kind of current I'm going to demand from it, but apparently it can do it. And away I'll go. And this box from the outside will have and I'll mount it that way. So on the bottom of the white plastic, it'll have a start button, a power up, power down, toggle switch, and it will have on each side, one side will be power in and one side will be power out. And that'll be that. So hours of work to go, but there we go, the modules all work.